Let's talk about radicals and integer exponents. Radicals, just fancy word for square root or cube root. Integer is just a fancy word for numbers that don't have fractions or numbers that don't have decimals. So with all these things comes a few rules. And rule number one is, 5 to the third times 5 to the third. And I look at that in my brain and I say, well, that's just, 5 times 5 times 5. And then multiply that to 5 times 5 times 5. So that becomes 5 to the 6th. And some smarty pants is just going to break in the room and say, duh. All you have to do, sir, is add the exponents. The shortcut says if you're multiplying two things with the same base, add the exponents. So that's a shortcut. Much faster way. I see this guy, and rather than write it all out, I think, all right, well, I'm going to have 7, 7, 7, 7 on the top, and I have 7, 7, 7, 7, 9 of them on the bottom. So what happens is the top people fight the bottom people and kill each other off, which means I'm going to be left with a bunch of 7s, 5 of them to be exact on the bottom. Don't forget to put the 1 on top. And so rather than write it all out and say, well, people are going to fight, fighting's wrong, some smarty pants is just going to walk in the room and say, you can subtract the exponents. And that would probably be a much better idea. When you divide terms of the same base, subtract exponents. I would look at this guy and I would say, all right, well, I have 5 bags. And in each bag, I have 2 9s. So I dump that bag and 2 9s pop out. And I dump that bag and 2 9s pop out. And in the end, I'm going to have 10 9s, so 9 to the 10th power. Great. And then some smarty pants is just going to walk around and say, why don't you just multiply the exponents? And I would say, yeah, that's a much faster way of multiply exponents. When you have something in a parentheses to a power and you take it to another power, that's when you multiply exponents. And if you have a negative exponent, I'll just write it out. You move to the other side of a fraction bar. Move to the other side of a fraction bar. And you might be saying, what fraction bar? Well, if I wanted to, I could say 2 to the negative 8 is the same thing as 2 to the negative 8 over 1. So that would be me moving it to the other side of the fraction bar, making it 2 to the positive 8. And as I know from before, if I leave an entire fraction open like that, I have to put a 1 there. So 1 to the 2 over 8 is going to be my answer for that. My kids are pretending to play Punch-Out downstairs in the basement where I am in my man cave. All right. What if you have multiple properties going on? Don't fret. Combine everything you can up top. Combine everything you can on the bottom. Then do the killing. Then do the fight. So, let me zoom up. So, I have 5 to the 7th, 5 to the 8th, 5 to the 4th, all being multiplied together. That means I add the exponents. 7 plus 8 is 15, plus 4 is 19. So I have 5 to the 19 over 5 to the 9th. Now that I'm dividing my bases, I subtract exponents. Which one's more powerful? The top. By how many? 10. So my answer is 5 to the 10th. PEMDAS says I do everything inside my parentheses first. And inside my parentheses, I have a negative exponent up here and a negative exponent down there. So what I'm going to do is I'm going to move that guy up there downstairs and that guy downstairs upstairs. So 6 to the negative 8th is now going to be 6 to the positive 8th on the bottom. 6 to the negative 5th on the bottom is now going to become 6 to the positive 5th up top. and it's still all taken to the second power. But I could still do stuff inside the parentheses because I have 6 to the 5th over 6 to the 8th. So I have a 6 over a 6. Which one's more powerful? The bottom. By how many? By 3. So I'm going to end up with 1 over 6 to the 3rd squared. What this means is, like I said up here in the thing that you can't see, if you're taking a power to a power, you multiply exponents. I don't have exponents here. So 1 squared is just 1 again. But 2 times 3 is going to be 6, so 6 to the 6. That's my answer there. So these are tricky problems. And we'll see if we end up in our practice problems with anything wacky like that. We'll see. I hope. Wacky's not a bad thing. All right. My job here is to turn that into standard notation. I have 4.6. 4.6 times 10 to the 4th means I make that number bigger by 4 spaces. 4.6, move to the right. 1, 2, 3, 4, 0, 0, 0. And that ends up being 4, 6, 0, 0, 0. Easy. 8.112 times 10 to the negative 3rd. I'm going to put 8.112. And since this is a negative exponent, it's going to get smaller. So I'm going to move to the left. 1, 2, 3. Put a dot there and fill in 2 zeros. So in the end, I get 0.008112. Now I have to write it in scientific notation. So I have to figure out, where should I put my dot? Well, my dot's going to be in between the 5 and the 6 because I always have to choose a number in between 1 but less than 10. So 5.6 is bigger than 1 and smaller than 10. Since this is a small number, it's going to be 10 to the negative power. Since this number is smaller than 1, it's going to be a negative exponent. Negative how many? 1, 2, 3, 4, 5, 6. So 10 to the negative 6. Where should my decimal go for that one? 4.560. So 4.56. I don't need that O there. Times 10 to the, well, that's a big number, so it's going to be a positive exponent. This number is bigger than 10, so it's going to be a positive exponent, and it's going to be positive 1, 2, 3. Just like the first packet, this one is scheduled to only take 20 minutes long, so let's see how long it takes me to do it and explain it. All right, some of these are friendly, like this one. Some of these are not. What is the square root of 81? Well, easy, 9. Don't need to explain it. What number is a perfect square? A perfect square is a number that you can take the square root of and get a perfect number. You can take the square root of it and get an integer. So if, I honestly don't know the square root of any of these. I know that it's not going to be the square root of 156. And I'm pretty sure it's not going to be C, but let's double check. The square root button is you hit second is orange, and then x squared. Where is x squared? X squared. Boop. And so the square root of a 600 is terrible, which means it's not a perfect square. The square root of 529 is 23. Which means it is the perfect square. Remember, a perfect square is, can I take the square root of it and get a lovely number? Which number shows that guy in scientific notation? Well, remember from what we just did, scientific notation means I take my number and I make sure it's between 1 and 10. Bigger than 1, but smaller than 10. And that eliminates two possibilities. That eliminates C and D. Why? Because these numbers are too big. That's not scientific notation because those numbers are too big. So get rid of those. Now, I know the answer is going to be this guy because this is a small number and it's going to be a negative exponent. But let's just double check to make sure I understand why. My dot is supposed to be in between the 5 and the 1. So I have 5.19. And since that's a small number, my exponent's negative. How many spaces do I go to get from one dot to the other dot? 1, 2, 3, 4, 5. And so there you have it. What's the value of the cube root of 64? I know it's 4, but let's remind ourselves how to do the cube root on a calculator. You hit math, and then 4 gives you the cube root option. Math 4 gives you the cube root option, and so math 4 of 64 is going to be regular 4, like I said. Yes. Yes. You have another special delivery. Aw, I'll get it later, okay? I'm making a video for the internet. Thank you, love you. Which shows another way to write 6 times 6 times 6 times 6 times 6. 6 to the 5th. Oh, almost did the wrong one. 6 to the 5th. Pretty easy. What is the standard number represented by 3.8 times 10 to the 5th? Well, let's write out 3.8. 10 to the 5th makes the number bigger, so you're going to move to the right 1, 2, 3, 4, 5 times. You're going to fill in 1, 2, 3, 4 zeros, which is going to be that guy. Scientific notation. All right, well, let's eliminate the one that doesn't make sense because the number's too big, so it can't be A. I'm supposed to put a dot in between the 4 and the 6, so it's 4.64 times 10 to the negative. Why negative? Because that's a small number. So that eliminates U, and that eliminates U, and we have our answer. But let's just double check. Let's see how many jumps it takes to get from one dot to the next. 1, 2, 3, 4, 5, 6. What is the value of 3 to the negative 2? Well, negative means I move it to the other side of the fraction bar. What fraction bar? Well, there is none. So I'm going to pretend that this is over 1. So when I move it to the other side of the fraction bar, it's going to be 3 positive squared on the bottom with the 1 on the top. Now, none of these say 1 over 3 squared. But you know what? I know what 3 squared is. It's 9. So that's the same thing as 1 over 9. A cheap way of doing this is you do 3, and then the to the button is the caret there, to the negative 2 in your calculator. 3 to the negative 2, and it's going to give you 0.1 repeating. Which one of these is 0.1 repeating? Well, 1 divided by 9 is 0.1 repeating. And we know that because when you're repeating a decimal, you put it over 9, and 0.1 repeating is 1 over 9. We know that from the last section. Tying it all together. All right. 2.48 times 10 to the third in standard notation. Let me write out 2.48. 10 to the third makes the number bigger, so I'll move to the right 1, 2, 3 spaces because it's 10 to the third, and that gives me 2,480. If you're like totally lost on some of these, you could just type that into your calculator and see what that calculator gives you. 2 to the negative 4 is very similar to a problem we just did. So I know that I'm going to put that on the other side of a fraction bar. So it's going to put 2 to the 4th on the bottom because to the negative 4 is on top. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 1 over 2 to the 4th is 1 over 16. Which one's not a perfect square? Remember, a perfect square is, can I take the square root of it and get a pretty number? Let me see. The square root of 81 is 9. So you're a perfect square, so I don't want you. The square root of 111 is, I don't know. The square root of 121 is 11. So that's perfect. I don't want you. And the square root of 225 is 15. And that's perfect. So I don't want you. So it was B. The one that I said I don't know to is not the perfect square. This is a perfect square. I believe it's 21, but I'm going to check. Second x squared gets me my square root button. 441 is going to be 21 like I thought it would be. All right. Couple more on this side. Ooh. All right, PEMDAS says we have to do everything inside the parentheses first. So this first guy is going to become, I do that all the time. This first guy is going to become 6 cubed times, and let's do this. 6 to the 4th times 6 squared, multiply exponents. So that's going to become 6 to the 8th. You add these exponents because 6 to the 3rd times 6 to the 8th, when you're multiplying bases, you add the exponents. Don't need those parentheses. 6 to the 11th. That guy right there. (20 minus 3 squared is 20 minus 9. So I can handle that one. Pretty easy. Second page only has a few problems, so let's blow it up. Let's blow it up. The top of a square table has an area of 256 square inches. What is the length of each side of the table? If you're given the area of a square, the way you find the side is you square root it. So, square root 256. I think it's 14, but I'm not sure, so I'm going to go to my calculator, hit second x squared to get me my square root button right there. I'm going to type out 256, hit enter, and it's 16. Ooh. So what is the length of each side? 16 inches. Remember, if I want to find the area, I square a side. So if I'm given the area, I do the opposite and I square root to find the side. Similarly, if I want to find the volume of a cube, I cube a side. But here, I'm given the volume, and what I want to do is cube root the volume to find the side. So the cube root button is math 4. So there it is. There's my cube root. And I'm going to type out 125, hit enter, and it gives me 5 centimeters. Remember, if I'm working backwards, the way I work backwards of a square is a square root. The way I work backwards for a cube is a cube root. Pretty easy. All right. Put that in scientific notation. So my dot needs to be in between the 4 and the 0. So it's 4.02. That's a big number, so it's going to be a positive exponent. So times 10 to the, and I'm going to go 1, that looks terrible. 1, 2, 3, 4, 5, 6, 7, 8 spaces to write that out in scientific notation. 4.02 times 10 to the 6th. PEMDAS says I work inside the exponents first. 9 squared next to 9 to the 6 means 2 9s next to 6 9. So I have 9 to the 8th. So let me write that here. 9 to the 8th divided by 9 to the 4th times 9 to the 6th, which is 6 of them. When you divide numbers of the same base, you subtract exponents. So there you have it. Worst case scenario, if you're like, I have no clue what to do, type the whole thing in your calculator. Just type the whole thing in your calculator and see what you come up with. 2 to the 4th times 2 to the 5th has me multiplying exponents, so 2 to the 20th. Let's see how many 8s I have upstairs. I have 8 to the 6th times 8 to the 3rd times 8 to the 5th means I do 6 plus 3, which is 9, plus 5, which is 14. So 8 to the 14 up top. I have 8 to the 9th and 8 to the 6th on the bottom. So that's 8 to the 15th on the bottom. So I'm going to subtract exponents. The 8 on the bottom is more powerful by how many? By 1. So I have 1 over 8 to the 1st, 1 over 1/8, which is 1 over an 8. Ooh, I got one crack there. Well, that's it for today. Packet 2 is done. I hope you had as much fun as I did. Bye!